In this video, we'll take a look here at example number 4 to try to see if we can understand how we can take a function and create a gradient vector field out of it, and also to reiterate the ideas of what it means to have a conservative vector field. So take a look here at example number 4. I have a function here of 3 variables, and I'd like to ask in part A if I can find the gradient vector field of f. Now notice that this question is so incredibly easy because really all we're being asked to do is to just find the gradient of f, which we know automatically takes in x comma y's comma z's and spits out a vector. And I do this by just creating my partial derivatives. So really quickly, I'd ask you to pause the video and see if you can create those partial derivatives, and then hit play again when you want to see the answer. All right, so here are the partial derivatives that I ended up with. If I take my partial derivative with respect to x, I get y and then e to the z. Partial derivative with respect to y is x e to the z. And partial derivative with respect to z is actually just xy e to the z. Nothing really changes there. So automatically, I have a gradient vector field. Now in part B, I can ask the question, is the vector field that we found up above conservative? I'm going to ask you again, pause the video and see if you can reflect on the idea of what it meant to be a conservative vector field, and then see if you can answer yes or no. When you're ready to see the answer, you can hit play again. Okay, so the answer that I would come up with here is definitely yes. And the reason I know this is because in order to be conservative, you just have to have some function that can create this vector field upon taking its gradient. This is because f of x comma y comma z is a potential function for this vector field. Since I automatically have a function that when I take its gradient, I end up with this vector, I'm golden. That was the entire definition of being conservative. Can you find a function whose gradient will create exactly this? And of course, in this case, then, that's unbelievably easy. We were given that function right from the start. As I state down here at the bottom, later on in chapter 5, we'll discover that conservative vector fields have a lot of very nice properties that we'd like to take advantage of, and it's the reason for their introduction here. In the next video, we'll start to take a look at the concept of line integrals.